This is one of the big ones. This is a video I've been preparing for months. A while ago I set an objective, and that objective was to create a system that would allow developers and ops people to live in a symbiosis, like a happy couple. And happy couples are people who do not demand something from each other. Now, if we translate that to devs and ops, or people on the left and people on the right, that would mean that ops should create services that devs consume instead of ops reacting to demands of devs. Give me a cluster, deploy my application, monitor my application, do this, do that. So the mission was to create a system that would allow ops people to enable devs to do everything by themselves, to enable some kind of self-sufficient teams. And that means that those teams should be able to manage their own infrastructure, to manage their own applications and everything else in between. So I evaluated a bunch of tools, and many of those resulted in videos in this channel. When infrastructure is concerned, I went through Pulumi and Terraform and Ansible and Crossplane. And Crossplane turned out to be the best fit for what I'm trying to do. And then I went through tools and frameworks that allow us to deploy and manage our applications. Some of the examples would be Portainer and Shippa and Catch and quite a few others. But they all suffer from the same problem, and that problem is that they are too opinionated. They do not enable ops to create services that devs can consume. Instead, they are opinionated. Like, hey, this is how you deploy your applications, and this is how you manage applications, and this is what your applications are. And many of those tools are great if that's what you want. But in many situations, that is not enough, because my applications might not fit into the mold created by third-party vendors. What I want is a tool that will enable ops to create patterns and services that devs can consume. And that applies equally to infrastructure as to applications. When infrastructure is concerned, I already mentioned that the tool of choice, at least my choice, is Crossplane. And when applications are concerned, the best candidate to accomplish that is KubeVela with the Open Application Model. Finally, I do not want devs to think about clusters and VPCs and Kubernetes and what's or not. Those are important things, but not necessarily something that devs want to dive into. I want ops to create services that will enable devs to think about the things that matter to them and not to infrastructure and the services and all the details that ops people do care about. And so that led me to GitOps. So instead of devs using kubectl or Helm or this or that, they should just push their changes to Git repository and then magic happens. And for that, my choice is ArgoCD, even though you get more or less the same results with Flux. Now, if you did not come to this channel for the first time, you already know that I published video about each of those topics or each of those tools. Those videos are a result of months-long journey that led me here to this moment and this video. In this video, we are going to combine all those things and make a system that will enable ops to create services for devs in a way that devs will be happy to use them and will be happy to be autonomous. So let's go and see whether we can get to that nirvana state of shifting everything left. I already created a control type of cluster where I installed ArgoCD and Crossplane, and I already have a base Git repository that contains everything we will need for this demo. If you want to follow along, all the instructions, all the commands and references are in a gist, and the link to the gist is in the description of this video. And this is what I got so far. This is ArgoCD web UI that contains all the applications that I will need for this demo. And the most important one, the root application, is called production. And if I go inside of that application, we can see that there is ArgoCD and Crossplane compositions, Crossplane configs, Crossplane providers, sealed secrets, and Team A infra applications. I will not go into details of what they are. You will find videos for each of those tools. This is not about going into details of each one of those. I assume that you are already familiar with Crossplane and with ArgoCD and with KubeVela. What matters is for me to show you how all that combines together. And to do that, we are going to do some sort of role-playing. There are two terminals, and the left terminal contains the operations that developers would normally run, and the right-hand terminal contains the operations that ops people will run. And one of the first things the devs need is a cluster. Hey, I have my application, or I will have soon my application, I need a cluster to run. And this is how devs can define those clusters. There is a composite cluster, which is just a random name that ops decided will be the name of that type of definition that devs can use. And there is intentionally not much going on here. It needs to be simple. And simple means, hey, where do you want your cluster in AWS? Excellent. What is the size of the nodes you want? Small. Brilliant. Do you want to specify anything else? No need. Even better. And there is no need for you, dear developer, to interact with those clusters or do anything special. All you have to do is create simple definitions and push them to Git. And once new definitions or modified definitions are in Git, ArgoCD can take over and just do whatever needs to be done. As an ops person, on the other hand, I can monitor the situation and see what's going on. And I can see that that simple definition created a bunch of resources. There is a cluster, node group, roles, policy attachments, VPC, security group, subnets, internet gateway, route table, some Helm config, and Helm release based on KubeVela chart. It takes time until all those things are created, so let me fast forward. Now that everything is created, the whole infrastructure is up and running, there is one step that I was too lazy to fully automate and inject into Crossplane, so I created a simple script. Anybody can run that script just does the final touches within that newly created cluster. What matters is that me as a dev now have a cluster that I can use for my own purposes, and I can start deploying my applications. And as I mentioned before, there is no need for me as a dev person to really go into details of Kubernetes, start defining ingresses and virtual services and storage and deployments and stateful sets and all that madness that never ends. Actually, it's a cool type of madness. I love it, but I understand that majority of people do not have time to understand all those things and go into all the details that we need to go to when we are dealing with Kubernetes. So I, as an ops person in this case, created another layer of simplification or another service using KubeVela. And after speaking with developers and getting their requirements and understanding what they really need, I created some components and some traits and told developers, hey, you can use those to construct your applications and focus on what matters to you. And as a result of that, we have something similar to what you see here on the screen. And that is an application. It's nothing specific to Kubernetes, but an application that is very simple to define. And this imaginary developer decided that that specific application should have two components. One is called backend, and that backend component has some properties like the image and the command. I mean, this is a silly example, but it can be whatever ops defined it to be. And there is frontend with yet another round of properties like, hey, this is the name and this is the image that should be used for that frontend application. But frontend in this case is more complicated. It needs to auto-scale and it needs to be accessible from the outside world. And the developer did not define that by defining horizontal pod autoscaler and ingress and deciding which ingress to use, but by defining a few traits. One is called autoscaler, which says, hey, the minimum number of replicas should be 3, the maximum, whatever somebody else defined, I don't care about the maximum. And it is exposed to the outside world through ingress. Which ingress? I don't know, I don't care. What I do care is that there is the domain and there is the port. And that's about it. This is the definition of an application that is completely agnostic from Kubernetes and serverless or this or that. The implementation is a completely different story. What matters is that this application is defined as application and not as a collection of resources that potentially many people do not even understand. So what do I need to do to have this application running in my cluster? Well, nothing special. Just create a file that manifests in a specific directory in a Git repository that is monitored by ArgoCD and push those changes to GitHub. In this case, GitHub. It could be GitLab or whatever else you're using. And the next step is, well, nothing. There is no next step. Just create simple definitions, push to Git. If you need infra, it's simple, push to Git. If you need applications, again, it's simple, push to Git. I, as a developer, have freedom to do what I need to do without being forced to spend months or years trying to understand all those details. So it's freedom with rails. And those rails were created by ops, and freedom is to do whatever I want to do within the space that was given to me. Now, as an ops person, I can dive into that cluster and see what's going on. So I'm going to export kubeconfig variable to point to wherever the configuration is for that cluster and start watching for the resources in the newly created cluster, to be more specific, in the production namespace. Initially, there is nothing because it takes anything between 1 second and 3 minutes for ArgoCD to pick it up. The frequency can be changed, but in this case, I left ArgoCD with the default settings, and default means up to 3 minutes until the next synchronization interval. And then, all of a sudden, out of nowhere, my application appeared. There are pods and services and deployments and replica sets and horizontal pod autoscalers and ingress and all the jazz is there. Everything that had to happen for this application to run really well is there, while the definition is extremely simple, very developer friendly. Me as ops created that definition, while he as dev is using that definition in any way that that person would like to use it within the limits of that service. And that was it. That's all there is to it, at least from the user perspective. Now let's take a quick look at how all that happened. I, ops person in this case, created ArgoCD application that points to a specific directory in a specific Git repository. So whatever is pushed there will be applied somewhere. And that directory is production. And if I list the files over there, I can see that there is the definition of ArgoCD, Crossplane, sealed secrets, and the specific files for this specific team, which I call Team A. I'm not creative, so that's the best name I could give to that team. And those applications are based on the up of ops concept in ArgoCD. And if I look at one of those applications, which is Team A Infra, we can see that it is pointing to yet another Git repository, which in this case happens to be the same, but it could be a different one, and a specific directory, which in this case is Team A Infra. So root application is watching the directory production, and that directory has different applications, and each of them is pointing to a different directory in a different or the same repository. And then if you take a look at Team A Infra directory, which contains the infrastructure for that specific team, there is the cluster YAML file, which is the file that dev created because he or she wanted a cluster and wanted it in a very simple way. And that simple way was, hey, here's the name, here's the minimum number of properties, go. And that was made possible through the definition, which contains all the parameters that define the contract that is between operations and devs. That's like a bridge that connects the simplicity exposed to developers and the complexity required to create that simplicity. But there is a complicated part, the part normally in the hands of ops, which is, hey, I need to define all those AWS resources. There is no way around it. We need to define the subnets and VPCs and clusters and node groups and all those things. And that's where composition comes into play. Composition combines all those resources and it exposes it to devs through a simple interface, which is a custom resource definition or the composition definition. Developer, on the other hand, had only to define cluster YAML, which is, I don't know, maybe 10 or 15 lines of YAML altogether, and that could be even smaller if I didn't put comments inside. And the same thing goes for applications, except that for defining applications, I'm not using Crossplane, but KubeVela, which is based on open application model, but the logic is very, very similar. There is component definition that defines what is frontend, and there is component definition that defines what is backend, and there are traits that can be attached to those components, and that's how we got scalar and ingress and what's not. But from a developer perspective, it's still very simple. This time there are maybe 25, 30 lines of YAML because it's an application with multiple components inside and multiple traits. Still, those 20, 30, 40 lines of YAML are equivalent to hundreds and hundreds lines of YAML that we would normally need to define for such an application. And this is a simple application. It could get much worse, for ops, not for devs. Or for devs if they are not having ops that are using something like this. And all that is happening by pushing changes to Git. Whom do you need to thank for that? ArgoCD or Flux if you prefer that one instead. And if at one moment devs want to change something, they just apply changes to the existing manifests and push them back to Git. And if they need to destroy something, they just remove the file, push changes to Git again, and that's all it takes. Create the file to create resources, update the file to update resources, delete the file to remove resources. And that's about it. That's all there is to it. Actually, there's a lot to it. There's a lot of work involved to set up a system like that. But once you do set it up, the results are absolutely amazing. If you want to shift left, if you want to enable people to the left of you, developers, testers, whomever, to take control of their own lives without going crazy, by making it simple for them, this might be the way to go. Now, I did not go into details of how this happened because I created already different videos for each one of those topics. So go and check out KubeVela and ArgoCD and Crossplane, and then once you're confident with it, come back to this video. Or actually, do not come back to this video. Go to the gist to reproduce this, because this combines all those things together with a few additional tools like sealed secrets, for example. So there we go. This is how we create self-sufficient teams that can manage everything by themselves within certain constraints created by you and through the services that you provide to other teams in your company.